Hello everyone, welcome back to my YouTube channel Algoptimize. In today's video, we are going to discuss about dynamic programming. Dynamic programming is a method for designing algorithms that divides a problem into sub-problems, then find solutions for the sub-problems, and finally put the solutions together to get the complete solution for our main problem. We use dynamic programming because it reduces time complexity, it avoids redundant calculation, which means the calculations that are performed again and again, and also it efficiently solves optimization problems and counting problems. Optimization problems are where we have to find the best answer, and the counting problems means the problems where we have to find how many ways something can be done. To be solved by an algorithm designed using dynamic programming, the problem must have two properties, which are overlapping subproblems and optimal substructure. Overlapping subproblems mean that the problem can be divided into subproblems where the solution to one subproblem is reused as a part of solving another subproblem. Optimal substructure means that the complete solution for the problem can be built by combining the optimal solutions, which means the best solutions of the subproblems. That way, we can form the overall best solution. As a simple example of the usage of dynamic programming, I am going to use the Fibonacci sequence. Fibonacci sequence is a series of numbers where you can get each number by calculating the sum of two preceding numbers. This sequence often starts from 0 and 1. Here is the formula for the Fibonacci function. This n represents the input. And here, if we want to find the Fibonacci of the nth element, we have to sum up the Fibonacci n minus 1 and Fibonacci n minus 2. Before going into the example, mind that the Fibonacci sequence can also be solved by using recursions. Recursion is a technique where a function calls itself inside its body. With that being said, let's see how dynamic programming works with this Fibonacci sequence. In here, our problem is to find the fifth element of the Fibonacci sequence. The fifth represents Fibonacci sequence, and since we have to find the fifth element, we are sending the input as 5. And to solve this problem, we divided that problem into subproblems. And as you can see, the subproblems are overlapping, because in here we can see fib tree, and here also we can see fib tree, and in here we can see fib 2. So the subproblems are overlapping. Then we can apply the dynamic programming for this problem. Before beginning this process, we have to set the base case. Base case is the condition that stops the process from running infinitely. Since each number is calculated by adding up the preceding two numbers, we can include two conditions into base cases, such as if n, which is the input, equals 0, the return should be 0. If input equals 1, the method should return 1. When using dynamic programming, it stores the found values and reuses it to find solutions for other subproblems. Since we already know the answer to fib 1 and fib 0 because it is given in the base case, we can calculate fib 2 as 1 plus 0, and then the answer will be stored as fib 2 equals 1 because 1 plus 0 is 1, and then we can add 2 in fib 2 into fib 1 and get 1 plus 1 equals 2, and therefore fib 3 is 2. As you can see, we have already found the value for fib 2 in here, and it is stored in the program. So no need to calculate this. We can simply cancel this and get the stored value as 1. So 2 plus 1 equals 3. It will be also stored in the program. So fib 4, the answer is 2 plus 1 equals 3. And here again you can see we have already found the value of fib 3 as 2. So we can apply 2 in here instead of solving this subtree, and fib 4 equals 3 and fib 3 equals 2, which add up to 5, and it is the answer of fib 5. So we have finally found the fifth element of the Fibonacci sequence as 5. If we are using recursions, there is no way to store the found value, and we have to always calculate the same subproblem again and again. But in dynamic programming, since we are storing it, we can simply reuse it to find solutions to other subproblems and get the solution for the whole problem. Finally, let's see how dynamic programming differs from recursions. Dynamic programming solves each problem once and store the results for reuse, resulting in reduced time complexity, while recursions calculate same subproblems multiple times, resulting in high time complexity. As for memory usage, dynamic programming uses extra memory for arrays and tables to store solutions of the subproblems, while recursions only uses call stack. Dynamic programming is efficient than recursions because dynamic programming avoids recalculations, and recursions are inefficient for large number of inputs due to the recalculations. Dynamic programming is used for optimization problems and counting problems with overlapping subproblems, while recursions are used for simple problems where repeated work is not costly. That marks the end of today's video. If there are any further questions, please feel free to use the comment section below. And if you found this video helpful, please like, subscribe and share among your friends. Thank you for watching and have a nice day.